Starship completes its wet dress rehearsal. Another problem for Webb. A nuclear rocket test is coming, and more cool NIAC grants. All this and more in this week's episode of Space Bites. We haven't heard a lot of news about SpaceX Starship recently, but we got a pretty significant test this week, and that's a full wet dress rehearsal. And this is where SpaceX goes through the entire process of preparing the full stack rocket for launch. So both the Super Heavy and the Starship on top, both sitting on the launch pad, both completely fueled up with propellant. They then count down the clock, and then instead of launching, they stop and drain all the propellant and learn all of the lessons and make sure that everything is ready to go. But that's a really important stage. It shows that every part of the system is pretty much complete, that the tanks are able to hold the propellant and hold the pressure, that everything seems to be operational and ready to go. And so this means we're getting pretty close to seeing a full orbital launch of Starship with the Super Heavy and the actual Starship rocket on top. According to SpaceX, they put in 4.5 million kilograms of propellant, which is about 10 million pounds of propellant. And the cool thing is that because Starship is made of metal, stainless steel, you can actually see the line as the propellant is filling up on the rocket because it's so cold, and you get this frost forming on the outside of the rocket. So what's next? Well, there's one big remaining test that we're expecting them to do, and that is going to be a static fire test of the Super Heavy with all 33 Raptor engines. So at this point, they've only tested about a dozen engines at a time, but we're still waiting to see whether all 33 engines will fire at the same time. And if that test is complete, then they're pretty much ready to go orbital. And Elon Musk posted on Twitter and said about as much. He said that we may see a launch in February or March. And of course, I believe I've been predicting March for a very long time now, and I really, I feel like I'm gonna nail this one, but we'll see what happens. But yeah, in the next month or so, we could see a launch of the SpaceX Starship with the Super Heavy booster going to orbit and then hoping to return safely back to Earth. And of course, NASA is watching this progress very carefully because Starship is going to be the human landing system for the upcoming Artemis missions. And that's going to be for Artemis 3, which is going to be, like around 5 years from now. And so up until that point, they need to be able to launch Starship, refuel it in space, fly it to the moon, and be able to prove that they can land on the moon and return safely to orbit. And only then will NASA feel okay about having its astronauts step out of their Orion capsule and into Starship to travel down to the surface of the moon. So there are definitely a lot of steps remaining before we can actually see this as part of the Artemis mission, but still, it's pretty exciting to see the progress. There's another problem with Webb. A few months ago, there was a problem with one of the instruments on Webb, and the engineers decided to take that mode offline until they could sort out the problem. There was some additional friction in one of the filter wheels, and they've been able to sort of work around the problem, not completely make it go away, but enough that they can continue doing their science. And this week we learned there is a new glitch on Webb, and this has to do with the near-infrared imager and slitless spectrograph. And this is actually a Canadian-built instrument that is on board JWST. And it has 4 different modes. Now, it can work as a camera looking at the infrared light, but it also is a spectrograph. And so it can do things like study the atmospheres of exoplanets or examine the light curve from distant galaxies to help figure out what it's made of and how quickly it's moving. So it has a lot of uses. So what's going on? Well, NASA diagnosed that there's some kind of communications delay going on within the instrument. And who knows if this is the beginning of a bigger problem, but they're not taking any chances. So NASA's decided to take this instrument offline and diagnose the issue, run a bunch of tests, and hopefully they can bring it back online. But there doesn't seem to be any physical problem, no electrical problem, just this strange communications delay, like probably a software issue. And so it doesn't sound like a really serious issue, but still the kind of thing that they want to take offline and work through and make sure they get it solved before they make it operational again. Now, it's not only bad news about James Webb, we've got some good news. We've got a really interesting observation. And this time, Webb was called on to observe a centaur called Charlcoe. And centaurs, this is a group of objects that are located in the outer solar system, like with Uranus, Neptune, beyond the orbit of Saturn. And this object has been known for quite a while, and we've known since 2013 that this object has rings. The way astronomers found these rings in the first place was they observed an occultation. This was a time when this tiny centaur, it's only about 250 kilometers across, passed directly in front of a reasonably bright star. And astronomers were able to watch as the centaur passed right in front of the star, and they noticed that it dimmed before it actually passed in front of the star, and then dimmed after it passed in front of the star. And they were able to map out that it has a set of rings. Now, the rings are probably not like Saturn's rings. They're more like Uranus or Neptune's rings, like icy rings with dirt and other dusty material mixed in. They're probably quite dark. And so the astronomers that made that initial discovery noticed that there was another interesting occultation coming up where Charlcoe would go in front of another star. And they had some discretionary time on James Webb, and they decided to take advantage of that and make some observations. And they're able to observe as the star dimmed briefly as the rings passed in front of it, and then dimmed as the actual centaur passed in front of it. And because JWST is such a powerful telescope and it's designed to look at very cool objects, it was the perfect instrument to be able to observe the rings and the centaur itself. And this is the beginning of what will probably become a pretty long series of observations. With more occultations in the future, they'll be able to better map out the shape and the size of the rings. And you're probably wondering, like, how did some object out there get rings like this? And it's believed that at some point in the past, another smaller object crashed into Charlcoe and was able to generate this debris that then turned into the rings that now orbit. And because the images of the rings show that they're actually very sharp, very well defined, it might mean that they're actually shepherd moons inside the ring system that are keeping the rings organized, similar to what you can see orbiting within Saturn's rings. So I think we're going to hear a lot about this object, and we'll see many more follow-on observations over the coming years. Each time there's an occultation opportunity, we will see more information about this object, and we'll learn a lot more about the outer solar system. An asteroid just flew past the Earth, but don't worry about it. You probably got a lot of hype and people freaked out about this recent asteroid flyby that passed the Earth on Thursday. It came within 3,600 kilometers of the Earth. It's about 2,200 miles, and that is amazingly close. Like, it's very rare that we see an asteroid fly lower than, say, geostationary orbit, which is about 35,000 kilometers. And definitely, very rarely do we see them come within the Earth and the Moon, which is around 400,000 kilometers. This was 3,500 kilometers. So that's very close. The object is fairly small. It's about the size of a box truck. And if it had hit the atmosphere, it wouldn't have done any damage, really. It's smaller than Chelyabinsk. It would have exploded in the sky. People would have seen it, and maybe some debris would have rained down, and people could have tried to collect it and do some science on that. And once it made its flyby, it then got a pretty significant gravitational kick and changed its orbit quite dramatically. And so before it had a roughly circular orbit, now it's got a fairly elongated orbit. It's going to take it out in between the Earth and Mars. What's unnerving is that this happens fairly often, and most of the time we never learn about it. Like, we learn about the objects that actually crash into the atmosphere because it's very bright and it's detectable. But it's very rare that we have an object that comes that close and we notice it. So as our telescopes get better, as we have spacecraft that are looking for asteroids, we're going to hear this happen a lot more often. You're going to get this last minute announcement. Oh, by the way, a big asteroid is going to come very close to the Earth. And you don't realize the shooting gallery that you were always in. If now you're aware of it. Is that better? I don't know. NASA and DARPA are going to be testing a nuclear rocket. You've probably heard me making a lot of announcements about nuclear rockets in space, the nuclear reactors in space, fusion power. It's hard to keep it all straight. I'm having trouble keeping it all organized, all of the interesting ideas that are coming up that are going to be involving nuclear rockets in some way. And so we got an announcement this week that NASA and DARPA are collaborating to test a nuclear thermal propulsion rocket in space by 2027. And this technology is ancient. The last time one of these nuclear thermal propulsion rockets was tested was about 50 years ago. And what they do is they take a fission reactor, like the kind of thing you have in a power station or in a nuclear submarine or a aircraft carrier, and they use it to heat up some kind of propellant to an incredible heat and then blast it out the back of the rocket at a very high velocity. And nuclear rockets are great because they have a very high specific impulse. You can make your rocket go faster with the same amount of fuel. So it should theoretically allow you to shorten the flight times to get to Mars, for example, carry less fuel to make the same journey in less time. So it's good all around. And obviously, because you're dealing with a nuclear reactor and trying to launch one of these things to space, there are some environmental concerns that people have had in the past. But at this point, we've seen nuclear material be flown to space, things like on Perseverance, Curiosity, New Horizons. And so I think people are getting more and more comfortable with this idea that the future of space exploration is going to include some kind of nuclear propulsion system, nuclear reactors to provide power to future Mars bases and moon bases and things like that. So if all goes well, they will have constructed a working nuclear thermal propulsion system and they will have flown it to space and will make it operational by 2027. And this is big. This is a big milestone. We've been waiting a long time for somebody to actually set a timeline for a practical test of a thermal rocket system. And it's pretty exciting that we're going to see this. And so we could see future missions to Mars have dramatically lower flight times thanks to this technology. Miniaturizing nuclear batteries. I mentioned nuclear thermal propulsion systems, but the method of nuclear power that is used in space all the time right now, it's on board Perseverance, it's on board Curiosity, it's on the Voyagers, it was on Cassini, Galileo, many different spacecraft use this. It's called a radioisotope thermal electric generator, or an RTG. That is the last time I'm going to say those words. It's RTG. And what it is a chunk of plutonium that is decaying. And as it decays, it gives off a tremendous amount of heat that can last for decades. And then that plutonium is connected with a thermocouple and they're able to generate electricity from the heat that's being expended. And so scientists have been trying to figure out, is there some way to make these things smaller and more efficient, but still simple? The nice thing about the RTG is they are dead simple. And so one of the NIAC awards that was announced in early 2023 was a plan to try to miniaturize an RTG. So right now, an RTG is about 200 liters, which is pretty big. And they think they can get an RTG down to about 0.2 liters, so 200 milliliters, less than a cup. And they think you can get the power density from 3 watts per kilogram all the way up to 30 watts per kilogram. And so you've got a much smaller RTG that's producing more power. And what's really exciting about this is that now other applications open up for RTGs. So in the past, you had to have these giant flagship spacecraft, but now instead of a multiple ton spaceship, you could have something that is smaller, bordering on CubeSat size, and yet still powered by this long-lasting energy source that could keep it going for decades. And so maybe we could see some of those missions to Uranus and Neptune after all. Instead of having to go the flagship route, you make one of these smaller RTGs and you can power your mission that's less expensive. Now, this is one of the new NIAC grants that were awarded in 2023, and we've got a story about this on Universe Today, and hopefully I'll be able to interview the people behind it. I haven't talked to them yet, but I'm hoping that I will, and you'll be able to see that interview here. Scientists build a teeny tiny tractor beam. Now, tractor beams are a mainstay in science fiction. When you think about Star Trek, they fire the tractor beam and drag things in. There's a really cool scene in the new Andor show where they had a tractor beam and a unique defense against the tractor beam. If you haven't seen Andor, it's really good. But of course, people want to see a practical version of this technology. Now, there is a version of a tractor beam that's been in use for quite a while, and they're called optical tweezers, and they use laser light to be able to shove microscopic particles around, and it works pretty well and is used sort of as practical applications for various science experiments. But can we do this with something that is larger? And so researchers have been able to create a larger version of a tractor beam, something that can actually move macroscopic objects around. But it's in a very specific laboratory condition. It's not like you can just fire this from the International Space Station to bring an astronaut back on board. They fire a laser at a target, and then the heat around that target is irregular so that hotter gas builds up on the far side of the object. And then that creates a pressure differential in the air that then pushes the object towards the laser, and they're able to drag this around. And it's still fairly rough. Like I said, it's just in the laboratory stage, but it's a first step. And who knows, maybe in the future we will see tractor beams installed on various spacecraft. If you like the work that we do, why don't you consider joining our Patreon? Now, I've had a chance to talk to a lot of the patrons who have signed up. It's actually one of the secret perks that I give, is that we can have a meeting after you sign up as a patron. And when I talk to a lot of people, they say, well, I've been wanting to for years sometimes, and I just never got around to it. We could use your money. If you want to become a patron, become a patron. It's really easy, and you get a lot of perks. Like, I will remove all the ads from the Universe Today website for life. You get advanced access behind the scenes. For example, you're going to get access to all of the NIAC interviews, probably for a couple of weeks before we're able to release them to the public. So join our Patreon community. Help us out. It's time. Sign up. Go to patreon.com/universe today. Could we grow structures on Mars? Speaking of NIAC grants, I had a chance to talk to one of the researchers who was awarded a grant, and this idea is really clever. One of the big outstanding problems with living off the land on places like Mars or the Moon is you've got all this regolith, you've got all this sand to work with, but how do you turn it into some kind of building material? There's been lots of ideas that have been proposed. You can use microwaves, you can heat it up in a kiln, you can mix up some kind of binding agent to make a sort of concrete out of it. And this idea is to use bacteria and fungi to act like a glue in between the regolith. So what you would do is you would build a bioreactor, and then inside the bioreactor you would have a mold for your building blocks. And then you would put the regolith into the mold, and then you would feed it material from Mars. So you would have the local atmosphere and maybe some water that you would put into the system, and cyanobacteria and fungus would grow together to glue all of the particles together. And then once they had finished, you could pull the brick out and it would be solid and you could build buildings out of it. But the really cool idea is that this life wouldn't be dead. It would just go into hibernation. And then if you had some kind of damage, you needed to fix something, you could put the brick in, put it back into your bioreactor, grow new material and heal the brick, and then put it back into your building. So it's a very clever idea, and could have some applications here on Earth as well. What if we grew buildings instead of building them out of material? I like the idea. Light pollution is getting worse. Do you remember when you used to be able to see the Milky Way and now you can't? Well, it's not just you, it's everybody. And that's because our light pollution is just getting progressively worse. We got an announcement from the Globe at Night, which is this citizen science group that are tracking the levels of light pollution around the world. They have a really cool program. What they do is volunteers around the world will look at images of the night sky at varying levels of light pollution and then compare that to what they can actually see with their own eyes. And then they will say, okay, I'm able to see just a few stars, or I'm able to see a lot of stars, or I'm able to see all the stars. And then they report in what they're able to see. And from this data, astronomers have been able to say that the light pollution is getting about 10% worse every year, and has been doing this as long as they've been tracking this, which is now about 11 years. And we're at the point now where about 30% of humanity can't see the Milky Way. 80% of Americans can't see the Milky Way from where they live. I can't even imagine like not being able to see the Milky Way. That would suck. And I think most people, they don't realize how special and wonderful it is to be able to go outside, look up, and be able to see all the stars, the planets, the Milky Way. It's important. And that night sky is being taken away from us bit by bit. And the reason is because of exterior lighting. We've had this revolution in lighting thanks to LEDs. They're dramatically less power. And so instead of, hey, let's conserve power and still get the same amount of lighting, the direction that people have gone is, let's use the same amount of power, but put out dramatically more lighting. And so we're seeing the night sky disappear before our very eyes. And when we talk about satellite constellations like Starlink and things like that, they are just barely causing a problem to the night sky. Definitely a problem for astronomers. And for the average person, it's almost impossible to be able to see the light pollution coming from satellites. If you're mad about satellites, you should be enraged by light pollution from exterior lighting. It's not light that's being pointed down where it's useful. It's light that's being pointed into the sky where it is not needed. And this is just getting worse and worse year after year. And there's a lot of resources that you can use to figure out how to decrease the amount of light pollution that your home is giving off, your business, your city, and lots of communities are doing a great job of getting this under control. And they love it. It's really special to be able to live in a place where they've got the light pollution under control, that you can live, be safe, and still see the night sky. So if you want to get involved in this project, go to Globe at Night and they will be able to sign you up for next year's observations and chart how light pollution is getting worse. All right, those were all the stories that we had today. Now you can dive deeper into any one of these stories. There are links in the show notes down below. You can also get even more space news in my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at university.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at university.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Tim Whalen, Dave Verabioff, Josh Schultz, and Andrew M. Gross, who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news we had today. A lot of news stories. We'll see you next week.